Okay, so we're going to talk about 6.1 tonight, and that's composite functions. When we're doing a composite function, we're inserting one function into the other. I mean, this is based on if I have f of x is equal to 2x minus 5, what is f of 3? And you have to take the x out and replace it with the 3, right? Okay. Well, now, instead of just having a single number, on a composite function, you have two functions. You have f of x is equal to 2x minus 5, and g of x is equal to negative 3x. You have two functions, and you're putting one function inside of the other. If I have f of g of x, another way of writing that more similar is f of g of x. I have to put the function g of x inside, just like I replaced this x with the 3. I have to replace this x with the function of g of x. So I would have 2 minus 5, everything from this function but that x, and then I'm going to put in the negative 3x. So that would give me a negative 6x minus 5, f of g of x. Okay? That's what we're talking about when we're talking about composite functions, inserting one function inside of another. All right, so just some practice on that using a table. Remember, we work from the inside out, right? So when I'm looking at f of g of x, I'm going to start with my g of x. So I have f of g, try to write it the same way the book does, f of g of 1. Looking at that table, that says start from the inside out. To begin with, what I need to know is what is g of 1 equal to? So when x is 1, what's g of 1? That's going to be 0, right? So if I need f of g, if I need f of g of x, and g, not x, I'm sorry, that should be a 1. And g of 1 is equal to 0, then what I need is f of 0, right? You get the inside function. When x is 1, g of x is 0. So g of 1 is 0. So that's going to set my f of 0. When x is 0, f of x is 5. So f of g of 1 is equal to 5. Ooh, huh? All right. I think I just kind of over-explained that one when it really isn't bad. I'm going to clear this. Start with your inside. Let's go f of g of 2. Start with g of 2. When x is 2, what's g of x? When x is 2, g of x is -3, right? So g of x is equal to -3. Now I go to the outside, and I need f of -3. So back to where x is -3, then f of x is 11. Yes, get the inside, plug it into the outside. How about g of f of 2? Problem C. You give that a shot. So f of 2, when f of 2, f of x is equal to 1, right? So that's my inside. I'm going to take the inside and do g of 1. So when x is 1, g is 0. So g of f of 2 is equal to 0. Yes? A little better? Okay. Those are actually a little bit easier, I think, when we're using the graphs. You can kind of see it. So let's look at when we have functions. Again, we're going to work from the inside out. So on problem 13, I have that f of x is equal to 2x, and g of x is equal to 3x squared plus 1. I want g of f of 2. So which function is my inside function? So I'm going to start out with finding what is f of 2. So if f of x is 2 times x, then f of 2 is 2 times 2. And f of 2 gives me a 4. Right? So I got my inside. Now I got to plug that into my outside function. So I need g of 4. 3 times 4 squared plus 1. 4 squared is 16 times 3 is 48 plus 1 is 49. So g of f of 2 is equal to 49. Kinda yes, kinda no. Okay. How about, let's try, f of x is equal to the square root of x plus 1. G of x is equal to 3x. How about f of g of 4? Oh, I'm sorry, I didn't. This is just some problems straight out of your textbook that I'm working up here. This is the paper that I'm up here on. All right, so where am I going to start with? Oh my gosh, I'm doing so well today. G is on the inside, so I need G of 4, which is going to be 3 times 4. G of 4 is equal to 12. Now that I have G of 4, I'm going to put whatever that's equal to. That right there is nothing but 12. Found out here. F of 12. Square root of 12 plus 1 equal to the square root of 13. So f of g of 4 is equal to the square root of 13. What you think? Okay. We need to do more on those, or are we good? All right. We're going to talk about the domain. And this domain business just keeps coming up and coming up and coming up. So we got to remember our 3 restrictions on domain, right? If I have f of x is equal to 1 over x, what cannot be in my domain, right? X cannot equal 0. If I have f of x is equal to the square root of x, x has to be greater than or equal to 0. In other words, positive. If I have f of x is equal to 1 over the square root of x, then x has to be just greater than 0, right? Because we can't have a 0 in that denominator. All right, and the other thing we got to remember before starting this section is that f of x is equal to x when y equals x, anything linear, all real, right? My domain is all real. What if I have f of x is equal to x squared, all real, or x cubed, all real, right? We got to remember when we have those all real. So for the first part, I'm going to be talking about for 23 through 26, I'm going to talk about what the composite function is. But if you notice, those are both linear, right? If the composite function, if the two functions separate are both all real, then the composite function together is going to be all real, right? So if I have f of x is equal to 2x plus 3, and g of x is equal to 4x. We started the night out looking at this kind of problem. If I need f of g, that means g is going into f, right? So I'm going to write f, dropping out that x. Replacing that x, I've got 4x, so I get 8x plus 3. Order counts. If I do g of f, that means that I am putting f inside of g. So that means I'm going to have 4 times 2x plus 3, giving me 8x minus or plus 12. Sometimes they'll do just make a composite function out of itself. So if I have f of f, can I not write that? Then I'm going to have 2, drop the x, plus 3. What am I going to put in replacing that 3? Another 2x plus 3, right? Because it's f of x. So we f of f. 4x plus 6 plus 3. 4x plus 9. Okay? How about you try and get me f of g, f of g and g of f, just our first two, a and b, f of g and g of f. Let's try that with problem 26. right? For f of g, I'm going to drop the x, have a plus 1 there, and get g of x in here, right? So that means I have x squared plus 4 plus 1. And this right here, guys, this little plus 1 at the end, that's where people tend to make the most mistakes. They leave that plus 1 behind. Make sure you put the whole thing in, and I've got x squared plus 5, right? G of f, I've got to put x squared and f of x has got to go inside of that parentheses, right? So I'm going to take out that, and I'm going to say x plus 1. When I FOIL out the x plus 1, I've got x squared plus 2x plus 1. And don't leave that last guy behind, right? Yes? Okay. All right. So when it comes to 29 through 32, we're not going to actually come up with the composite function, but what we are going to work on is the domain. Now the domain for all of these guys up here, because every one of them individually is all real, composite, they're still all real, right? But these, not so much, right? So we're not going to get the composite function, but we are going to be getting the domain. So for 29, the domain for f of g. For f of x, I have 3 over x minus 1. What restriction for just f of x? What's my domain? X cannot equal a 1, right? Because 1 minus 1 would give me that 0, okay? So how about for g of x? What's the restriction for 2 over x? X cannot equal a 0, right? All right, so for the composite function f of g, I'm going to start, your answer is always going to start with the restriction on the inside, okay? So automatically, the g of x has a restriction of x cannot equal 2, so I'm putting that, 0, and I'm putting that in my answer. Now I got to find out if there's a second one, okay? It's not 1. Because remember, I'm not dealing with them individually. I'm dealing with the composite function. And I'm going to have 3 over g of x minus 1, right? Because I got to put that g of x in where that x is. So what number cannot be here? A 1. So what g of x cannot equal? A 1, right? This g of x, this x over 2, it can't be a 1. Because if I have a 1 sitting here, then it's going to be 0. If I do my composite function, 3 over 2x minus 1, then I've got to set that equal to 0, right? 2x 2 over x minus 1 equals 0. Add that 1 to both. 2 over x equals 1 multiplying by that x. And x is equal to 2. So my second restriction is that x cannot equal 2. And that is my domain for the composite function. How bad is that? Not too bad? Kind of bad? What? Alright, let's do the same problem, except for we're going to swap it around and find the domain for g of f. Okay? Domain for g of f. I'm going to erase all of this. G of x. So I already know my first part. Your inside function restriction automatically goes there. So x cannot equal 1. Well, what would the composite function of g of f look like? This time, I need to put f into g of f. So if I said 2 over 3 over x minus 1, it can't be a 0. I gotta multiply. I gotta divide by 3 over x minus 1. How do you divide by a fraction, guys? Okay. So that means that I've got to multiply both sides by x minus 1 over, and this is going to cancel out with this, and what's going to happen over here? I'm multiplying by what number here? 0. So that means that I'm going to get left with 2 is equal to 0. Is that true? No. So what do I end up with? What do I know when I end up with a false answer? Something that's not true, like 2 equals 0. What's my answer when I end up with that? No solution. So that means that there's not another one. And I'm done with the domain for g of f is that x does not equal 1. All right, let's go after f of g. And we'll look at problem 30. Trying to find the domain for f of g. Find those separate restrictions first. What's my restriction for f of x? There you go. X cannot equal a negative 3. Yes, everybody gets this part right here. Yes, right? And then for g of x, x cannot equal, which one is going into my answer, all of us, from the get-go? All right, let's see if you can find that second one, if there is a second one. Right? Set that equal to 0. Negative 2 over x equals negative 3 multiplying by x. Negative 2 equals a negative 3x. Dividing by that negative 3, x is equal to 2/3. So x cannot equal 2/3. And there's my domain. Yeah? All right. Mm-hmm.
So how did you get rid of the 1?
How did I am not, remember when I'm talking about I'm not concerned about what's up here. When I'm talking about my domain, I just cannot have a 0 in that denominator. I didn't get rid of the 1.
So we just
All I know is that I can't have a 0 down here.
Oh, so we just focused in on the bottom.
Yeah.
Okay.
We just cannot have, that's a great question though. We just cannot have a 0 in that denominator. So that's what I'm trying to find out. What number out there would make my denominator a 0? And if I did that, if I did negative 2 over 2/3 plus 3. Well, these 2's would cancel each other out, and I would end up with a negative 3 plus 3, which would be my 0 down here, right? That's why x cannot be that. Does it make sense somewhat? Do we need to do another one? All right, the last question for the night. Yay. I know you would just stay here forever doing these math problems. Is to answer, would f of g and g of f be equal? Is f of g equal to g of f? Well, when you're doing that, all you're gonna do is find out, do they both equal X, right? Because if you think about it, if 3 plus 4 is equal to 7, and 5 plus 2 equals 7, then 3 plus 4 has to be equal to 5 plus 2, right? Okay, so if both of these will simplify down to an X, the same value, then they have to be equal to each other. So if I have f of g, f of x is 2x, and g of x is 1/2 x, then I have 2 times 1/2 x, right? And that 2 times 1/2 cancels, and that gives me f of g is equal to x. What about g of f? That's going to give me 1/2 times the 2x. And they're both going to simplify, so g of f is also equal to x. So since they both equal x, then they have to equal each other. And my answer is yes. So let's look at, how about 43? So if I have g of x in here, that means that I have 1/9 x plus 6. So what do I get for, I'm missing something, aren't I? So 1/9 times 9, those are going to cancel each other out, right? And that leaves me with x, x plus 6 minus 6, and I get left with x. And if I have 1/9 times f of x, 9x minus, this is supposed to be plus 6, Those sixes are gonna cancel, and I've got 1/9 times 9x, which again, just leaves me with an x. So yes, they are equal. Yes? Okay. Any questions? Online, any questions? Work on those domain problems for your composite ones, okay? Y'all, the car insurance, the car warranty people have gotten out of the country. Now they're coming from Canada.